Hi everyone and welcome to today's Physics Daily Booster. This is number 12 in our series, and do note this is an advanced information listed topic. So we're doing the topic of circuits today. To start us off then, what we need to know is what we're talking about when we refer to current. So quite simply, current is the rate of flow of our charged particles, which when we're talking electrical circuits will be those electrons. Now, in order to make current flow, we've got to have a cell, a battery or a power supply, and the circuit must be complete. This brings us on to one of our first little facts to learn, if you like, which is that in a series circuit, so a single loop, then the current will be the same everywhere in that loop. We may also see a question about conventional current. And in conventional current, the current flows from the positive terminal to the negative terminal. Now, that is the opposite direction to the way that the electrons actually move. So conventional current from positive to negative, and that's the opposite direction to the way the electrons move. Our next little bit is another calculation. So again, the formula is on your formula sheet, so do make sure you use that. Charge flow is current times time. Now remember, current is measured in amps and time measured in seconds. So just watch out for the time not being given in seconds there. What we actually find is in some questions, they could ask you to use some additional math skills here with converting, because rather than giving you a value in amps, they could use milliamps instead. So milliamps is the equivalent of a thousandth of an amp. So to obviously convert your milliamps into amps, all you've got to do is divide by 1000. We then come on to the whole circuits part. Now, what we actually find here is they could ask you a range of questions which do rely on you knowing the different circuit symbols. So what we can see here are the ones that you should know. I'd suggest putting obviously the symbol on one side of a flashcard, the actual component name on the other, and just test yourself until you can get them all right. I'm hoping a lot of these are very familiar to us from Key Stage 3, but we need to be able to use these because they could even give you questions asking you to draw a circuit diagram. So obviously you need to know the symbols to be able to do the diagram. When we actually think about our circuit then, in addition to current, there's another term that we need to know, which is potential difference, or PD for short. In order for a current to actually flow in a circuit, we need a potential difference. No potential difference, no current flows. Now, the reason we've got this potential difference is because inside our cell or battery, we've got this separation of those charges, the positives and the negatives. Therefore, what we have is a positive side and a negative side. In terms of what that means as far as our positive terminal and our negative terminal, then the positive terminal has a higher electrical potential than the negative. And this is what we're measuring, the potential difference, the difference between the positive terminal and the negative terminal. Potential difference itself is measured in volts, which has a symbol of a capital V, and the bit of equipment we use is a voltmeter. Now, when we are drawing any kind of cell, what we need to make sure of is we are using the correct notation. So the longer line is the positive terminal and the shorter line is the negative terminal. So please try to remember that when we're putting these into a circuit, positive is the longer line, smaller one is the negative. When we actually have our power supply, our cell, whatever it is, connected into our circuit, then what we've done is we've applied a potential difference between the ends of the wire. As a result of that, we set up an electric field inside the wire itself. There is another calculation that we need to be aware of here, which is the energy transferred. And quite simply, to work out the energy transferred, we do our potential difference times the charge. Obviously, we've already said that we can work out charge through another calculation, so don't be surprised if there are two parts to the question, or if we actually just have a kind of two-part calculation they're not explicitly telling you. So if we've got a situation where we've got a current, a time, and a potential difference given to us in the question, and they're asking you to calculate the energy transferred, you can't jump straight to that. You've got to work out the charge first of all, then you can multiply that by your potential difference to get your energy transferred. We're now going to have a little look at some of those key features about types of circuit, and we're going to start off with the simple one, the series circuit. We've already looked at this first rule, that in a series circuit the current is the same everywhere, i.e. everywhere those little red crosses are in the diagram on the left, if you put an ammeter there you would get the exact same reading. So remember that rule, it's going to come up not only in paper 1 but potentially in paper 2 as well. So series circuit, the current is the same everywhere. If we then consider the voltmeter, and they can ask us to actually draw a diagram to show how we would use this, the first point is how we connect it into our circuit. So if we were asked to draw a diagram for our voltmeter, you'd have to put it in parallel. So you see how I put like a little U shape basically with the wires and our voltmeter connected there around that one bulb. That's how we could measure the potential difference across the little bulb I've just labelled 1. Don't put the voltmeter in series. Has to go in parallel around the component we are looking at. Ammeter goes in series. What we find then is if we actually add up all of the readings on voltmeters across the components, then we actually equal the same reading on a voltmeter across the battery. So in our little example of the diagram at the top there, if we were to have a voltmeter connected around bulb 1, a voltmeter connected around bulb 2, and a voltmeter connected around our little cell up at the top here, then the reading on the one at the cell would be the same as 1 plus 2, so the 2 bulbs added together. Second type of circuit is the parallel circuit. Now parallel circuits have multiple loops, basically different pathways that we can see our current flowing through. Our first rule is that the current in all the loops add up to the current near the battery. So if we place our ammeter in positions A1 or A4 on this one on the bottom left here, they will read the same. And then if we add up A2 and A3, they equal the same as either A1 or A4. So what we find, the current in each of the loops added together is the same as the current near the battery. As far as the practical work goes, they could ask you some problem solving questions. So if you are trying to do an experiment with obviously a circuit and the bulb is not lighting up, what do? Well, first of all, you're going to connect the bulb directly to the battery. If it doesn't work, try another battery first of all. If that doesn't work, try a different bulb. Assuming that those two now work, then what we're going to do is check each of the bulbs in your circuit. So once you've checked all the bulbs, you are then going to go through checking all the wires. So what we actually find here is that when you're swapping out a wire, you only swap one out at a time. So obviously you connect just 2 wires, one from obviously one side of the battery to the bulb, one from the other side of the battery to the bulb. If that lights up, take out one wire, put a new one in. If it lights up, keep going until you've checked all of your wires. Last point about connecting things here is that you should connect the ammeter so that the negative terminal is nearest the negative terminal of the battery. If you don't do that, when you actually plug it in, what you're going to find is that you've got a negative reading on your ammeter. So just making sure negative terminal of the ammeter is nearest the negative terminal of the battery means that you're going to get that positive reading. Don't forget to join us again tomorrow for our next Daily Booster, and if there are bits that you're not 100% certain on from today's, then do have a look at the videos on the main channel, use your revision guides, just go back over that. It's always worth having a look at some of the past exam papers as well, just to get a little bit of a feel for the kind of questions that come up time and time again on circuits.